For loops, like while loops, are so useful that I thought it might be useful to take another look at them so that you'll get more comfortable with how to use them. I'd also like to give you another way of looking at the structure of a for loop a little bit more visually, so it's easier to remember when these various initialization and update steps occur. Here's a basic for loop, and we know what happens the first time we visit the loop. We do the initialization step, and then we do the test. If the test is true, we do the body of the loop, and then we eventually hit the closing curly brace. That sends us back up to the for loop, where we then do the update step. After the update, we do the test again. If the test is true, then we go ahead and execute the body of the loop, and so forth. It makes sense to have the initialization step as the very first thing in the list, but the update at the end is a little weird because it can be a little confusing to remember just when that gets applied. So let me suggest a little visual analogy. Let's copy this thing down, and now I'm going to do some weird typography. I'm going to turn some of the statements inside the for loop. So let's pull this up a little bit to give us a little bit more room, and I'll show you why I wrote it this way. The first time we come into the loop, we're working our way down the lines above the loop, and this is kind of the flow. This is the way I think of it. We reach the for loop, we do the initialization, we do the test, and we drop into the body of the loop. So it's like we're following the curve of this bowl. We come down the slope of I equals 0, the initialization step, we slide over the bottom of the bowl, which is the test, and then we go down into the loop. When we reach the bottom of the loop, we come back around, but this time we come around from the right-hand side. And again, we slide down the right-hand side of the bowl where we execute the update step. Then we go across the bottom of the bowl, which is the test, and if the test is true, we drop into the loop. When we reach the bottom of the loop, we come around again. And each time we come around from the right-hand side. We only go down the left-hand side the first time we enter the loop. So we go through the loop again, and when the loop is over, we come down the right-hand side, we do the increment, we do the test. So if you look at the picture this way, then the green arrow is the thing that gets done the first time we visit the loop. We come down, we do the initialization, the test, and we go into the loop. And every time from then on, we come in from the right-hand side. So we come down the update step, and then we apply the test. This little visual diagram with the funny typography, I hope gives you a feeling for how the for loop works. Let's actually step through it using the very same example that we used in the while loop. So I won't go through it all again, but I'll remind you of what it was. We had this picture with a bunch of boxes, and each box is wider than the one above it. And on each successive frame, all the boxes get longer. And so the loop is used to draw the 5 boxes, and then we use frame count to make the boxes longer on every frame. So let me quickly remind you of what this looks like when it's running. Here's the program running. I've slowed it down to just 1.5 frames per second, and we can see on every frame all the boxes get longer until eventually they fall off the right-hand side of the screen. But that's all this animation does. Let's now walk through the lines of the for loop as though we were processing. Just like in the video on the while, on the left-hand side we have the code, on the right-hand side the graphics output, and at the bottom the variables that we're interested in. Before we start, the variables y, top, and width have not yet been declared, so I'm just putting stars for their values, and frame count has the value 1. The red bar shows us where we are, and we're about to start the first line of the program, and that's, of course, setup. So we go into setup, we call size, it makes our graphics window. As with the while loop, typically here I would call smooth, maybe even set up some other things depending on what the program does. But for this simple example, we'll just get right out of setup and right into draw. So processing has just called draw. First thing we do is we call background. Bam, we set that up. We set up the fill color. We assign the value 50 to top. And at the bottom, you can see now top has the value 50. The value of width starts out as 50 times the current value of frame count. And right now frame count is 1, so width is 50. Now we're in the for loop. First thing we do the initialization statement. This is the combined declaration initialization that we saw at the end of the for loop video. It's a great little shortcut. I don't have to declare y all by itself. I can declare it right there in the for loop. It's just a nice feature of for loops. So here I am declaring the variable y and giving it the value 0. That's the initialization step. Now y has the value 0. We do our test. Is 0 less than 5? Well, of course it is. So into the loop we go. We draw a rectangle. Then we add 100 to the value of top. We add 50 to the value of width. We're at the bottom of the loop, and we go back up to the 4. And now, remember, we come in from the right-hand side. So the first thing we do is the increment. Y is currently 0. Now it's 1. And now we do the test. Is 1 less than 5? Yes, it is. So in we go. Draw the rectangle, bump the value of top, bump the value of width, hit the bottom of the loop, come back up, and the first thing we do is the increment. So now y goes from 1 to 2. And again, we test is 2 is less than 5. And you know how this goes. I'm just going to zip through it. We go around and around the loop. So now we've drawn 5 bars. We're near the bottom of the loop. So I'll go one more. Now we're at the closing curly brace and we're ready to go back up to the for loop. So let's take a look at the status of things before we do it. Looking at the bottom line, we can see y has the value of 4. Top and width are poised to draw another box if we need it. And of course, frame count is still just 1. So back up to the top of the loop we go. First, we do the update statement. In this case, add 1 to y. So y now is 5. And now we do the test. Is 5 less than 5? No, it's not. 5 is equal to 5. The test fails. We go to the first line after the 4. In this case, there's nothing more to be done. It's the last line of draw, and we're finished, and this frame is shown to the user. A 60th of a second later, processing starts draw again. So into draw we go. We call background. We set up the fill. We set up the top. Now width is 50 times 2. So the width of the first box is going to be 100, and we come back to the for loop. Because we are entering the for loop for the first time, we do the initialization again. Now you might be thinking, wait, no, we hit the for loop in the last frame. The way to always know if you're at the initialization or at the update is to ask yourself, which is the line you just executed? In this case, we just executed the line above the for loop. That's the line that sets the value of width. That says we're entering the loop. When the line that we've just executed is the closing curly brace at the end of the loop, bringing us back up, then we're repeating the loop. So here we are entering the loop for the first time as far as draw is concerned. It's the second frame, but draw thinks everything is new. It just created the variable top, it just created the variable width, and now it's creating the variable y. Giving it 0. Is 0 less than 5? Yes, it is. So we draw the first rectangle. Now it's wider than the last one. We add a couple of values. We come back up. We slide in from the right-hand side, increment y, and around we go. So let's go ahead and finish this frame. So there's our 5th box, and now we are at the bottom of the loop. Go back up to the top of the loop. Y is currently 4, so I'll add 1 to it. Y is 5. 5 is not less than 5, so we're finished, and the frame is done. Remember now, draw is finished. We don't have a background color set. We don't have variables named top and width. All the stuff inside of draw is essentially forgotten until a 60th of a second later when processing wakes up and says, hey, time to call draw again. Now it draws the background, it sets up the fill color, it creates the variable top, it creates the variable width. Now that's going to be 150 because frame count has the value 3, and we enter the loop fresh for this frame. We create our variable y. Certainly y is less than 5 because 0 is less than 5. We draw the new wide rectangle, and around the loop we go. So this is how a for loop can be written to draw the very same picture that we saw in the while loop example. As I mentioned before, both the for loop and the while loop do the very same work. And so the version that you pick, for or while, is the version that better fits the way you're thinking about your problem. You will see the for loop a little bit more frequently because it is more compact, and it has this extra little feature that it lets you declare that loop variable right there in the for. So the for loop tends to dominate, but you'll see lots of while loops, and there are lots of people who use nothing but while loops, and that's absolutely fine. Whichever version fits the way you're thinking about a particular problem, that's the one to use.